Hi everyone. Let me demo you an application, or actually 3 applications. One of them is called T-Service, which is on front of the others, and the other 2 called Water Service and T-Leaf Service. And T-Leaf Service and Water Service, they have their own databases. So that is basically our architecture, except you also have Eureka for service registry and discovery, so that these services can register themselves. And that means that you will also know what is running and when. So this is also the code stack. And these services, these are Spring Boot 3 based services. And also like with Spring Framework 6, of course. And we also added Spring Boot Actuator to these services to make them observable, which means that you will also get micrometer for metrics. And we also added Prometheus, which means that the application will publish metrics to a Prometheus server. And we added micrometer tracing for distributed tracing support with the Zipkin reporter, which means that all of these applications, they will send spans in the Zipkin format to a backend. So let me show you this application in action so that you can see what is going on. Okay, so this is the UI for the T-service, and this is calling the first service in our architecture. So what I can do here, I can just brew a small sencha, let's say, and you can get basically the recipe to do that. I can also do, let's say, a medium dahong pao, or I can brew like a large yokuru because I really like it. So that's what the...
Hey, Jonathan, are you busy right now?
Oh, yeah, like you are ruining my presentation.
Oh, sorry about that, but the users are asking to make some English tea and they're not able to get the recipe.
But the application just works.
Does it work for English tea though?
Like English breakfast, let me check. It should, oh.
Yeah, see, that's the problem, right?
Yeah, we are in trouble. Can you help me to fix it?
Yeah, sure. Let me take a look.
Okay, cool. Thank you.
All right. So like Jonathan mentioned, all of these apps are Spring Boot 3 apps, and they've got actuator and micrometer for observability. So we know that we're getting metrics from all of them, and we've got some dashboards set up here. So we can check the metrics for the app. And as he showed you in the architecture diagram, the T-service is the edge service here. And so you can see that we've got a dashboard and we're looking at the metrics for the T-service. And so we've got the throughput shown here, broken down into successful versus error results. And you can see that not everything is failing, which we saw in the UI, right? We were able to get sencha, we weren't able to get English breakfast. So you can see that some requests are failing, some are successful. Now we need to figure out why. So this confirms that it's not just a one-off error. We can see that it's happening to multiple users. And to drill down into that, it would be useful to look at traces, because then we can look at a specific request that a user actually made, and then we can figure out what went wrong in that specific request. Because here we can just see that an error is happening. All right, so we'll try to search for traces that have the T-service and have an error. So we will run that query, and we'll click on one of those. Then you can see here, there was indeed an error that was returned from the T-service. So this is a trace of a specific request that a user actually had, and you can see exactly how much time was taken in each service along the way. And you can see that the call hierarchy matches the architecture that was shown earlier, where you have the T-service calling the water service and the T-service calling the T-leaf service. So we can see that, and we can see the latency, and that there's no real issue with latency taken at each place, but we know that some error happened, and we want to figure out what that error was. So we can jump to the logs, and we can get the logs that correspond to this specific request throughout all the different services that were involved. And we can see that there's an error log here. So the error log is going to give us some more clues about what happened. We can see that it's logging that there was a 404, and we can see that it was calling the tleaf service here. So we see it was calling the tleaf service here. And you can see that this is making a call out to the database. And you can even see the query that's being made to the database because we have that kind of metadata attached to the traces. So you can really drill down and see exactly what's happening for any given user request. And then you can see here the result set span. And if we check the attributes, we can see that the row count was 0. So it's calling the database, it's not getting anything back. And that's why we're ultimately ending up with the 404 not found being returned to the user. So that's not good. And another thing that we can look at if we want to check the service graph over here, you can see that this is built based on the tracing data that actually comes from your services. And that tracing data should match the architecture that you expect. And we can see that it does, where it has T-service calling the water service and the tleaf service. And you can see it even broken down further based on the span names. So for HTTP, we have a common templated pattern here of HTTP, the method, and the endpoint. And then you can see the kind of rate at which things are being called there and the errors that are happening or not. And so you can see like you can see, for instance, that there aren't errors happening on a lot of these other endpoints. You can see that they are happening on this get T endpoint. So I showed how you can jump from the tracing data to the log data. We can also jump from tracing data to metric data. So this is useful if we're looking at a specific trace and maybe it seems like a lot of latency is being taken there, or it's got an error, and we want to see, because this trace is for one specific request that a user made, and we want to have information about what is the current state of things for aggregated across all users. So if we wanted to look at the throughput for metrics, we can query here and see for, say, the last 15 minutes, and you get a graph of the throughput. So that way you can jump from looking at a trace that involves the T service, and then you can look at the throughput for the T service. Or you could also look at the latency. And then this way you can get an idea of, okay, is this an issue just for this request, or is this an issue overall in general for users? But as we found out before, the issue is that English breakfast is missing from the database, so we need to go add that to the database. So I'll go over here. We've got English breakfast, and I'll go ahead and insert that into the database. See, that was successful. Now, to confirm that that was successful, we want to go back to our dashboard. And we saw before how we had this constant rate of errors happening in the T service. And if we give some time for the metrics to come in, because they're published periodically, we should hopefully see those errors go away. And we can even verify it in the UI, where now if we go to Steep English Breakfast, we get back the information that we're expecting and no errors. And we can do that multiple times. But of course, our experience doesn't necessarily match everyone else's experience, so we want to check the metrics so that we can see that for sure this is fixed for all users by verifying that the errors has gone to 0. That's what we want. No errors in our application. And now things look good.
Okay, cool. Now this looks good. Thank you, Tommy. I guess I can continue my presentation.
Hold your horses. You are ruining the latency in this app. Have you seen the graphs?
Oh, right.
Oh.
Like this seems really bad. Like before that, it was like around like 50 milliseconds, 100 range, and now it is like 350. This is really bad. Like, do you know what happened here? Oh, it's even higher. Can you help me?
Sure, I will help you out.
Solve this?
All I know is that I didn't break it. I'm going to go have some tea.
Let's see about that.
Okay.
Okay, so what should I do?
So how about we start by looking into the metrics of the process itself and the JVM?
Mm-hmm. Okay.
So what do we have here? We're picking the T-Service app.
Yep.
And what do you think about the heap usage and the CPU usage, etc.?
Heap seems okay. CPU usage, the CPU is basically sleeping. Nothing happens.
Mm-hmm.
GC confirms that. It looks good. Let's check if we have anything else here. Caches are okay. Metaspace class loading of heap buffers are fine. We don't have a lot of threads.
So it seems very stable from the point of view of the process, the drive.
Yeah, resource utilization seems okay.
Okay, so since we're in the edge service, let us double check if we do see the latency spike in the HTTP.
Okay,
side.
So this is throughput, that's fine. And yes, the latency is bad.
So we can definitely confirm that the latency is bad in the edge service, but it's not necessarily the edge service that is the reason for this latency spike.
Yes.
So do I remember correctly that the edge service is not using any database?
No, it doesn't. But
So,
it calls two other services.
Oh, it calls two other services. So we can double check which one of those, or both, are causing the latency.
Mm-hmm. Let's see that. So I can pick, let's say, TLeaf service. That's what Tommy was messing with. Maybe he caused the error. But yeah, resource utilization is completely fine. CPU is low, heap is fine, GC is okay. Let's check the latency.
So can we see if there is a latency on the HTTP side?
No, not really. There was like a small spike here, but that was like just like 80, 190 milliseconds, and everything is normal for the T service.
So can we safely assume that the TLeaf service is not causing the latency?
I think so. Let's check the water service. Heap is fine, GC is fine. Let's go down the data. Oh, okay. So this is bad.
So we can see in the water service that the latency is there on the HTTP side. So what this application is doing is it's getting the request, it's processing the request, and it's accessing the database, right?
Yes.
So maybe let's check if the latency is not there on the database side.
Mm-hmm. It seems that the connection latency is really bad. So this is the database actually, and it just went up really, really high.
So from the point of view of the metrics, we are able to confirm that most probably the reason for the latency is the database.
Mm-hmm.
I don't know about you, but I prefer to visualize things like on the trace view. Is there a way to actually see a trace before the latency spike and after the latency got introduced?
Oh yeah, totally. So we have exemplars, and exemplars are kind of like metadata that you can attach to your metrics. And this metadata is not like tags or labels attributes. They can have high cardinality data. So we are using exemplars in Micrometer to attach the trace ID and the span ID to our metrics. So if I go back to our dashboard here, see these small points and dots?
Are these exemplars?
Yes, those are exemplars. Let me make this see. So low latency, high latency, and these points are like the bad latency. You can see this like the the value of it is like 3.5 or 350 milliseconds, and this one is just like 70 something. So these high latency trace IDs, I can just copy one, and I can just open like one low latency trace ID, split this, and paste this here. And now, yeah, so what we can see here is this one is just 70 milliseconds, and this one should be, yeah, this is 370.
So do I understand correctly that to the left, we can see the trace view of a request that was fast, and to the right, we can see a trace for the request that was slow?
Exactly.
Okay, so we did manage to assume that the problem lays on the water service side, on the database side of that service. Can we visually confirm that here as well?
I think so. So see, the latency here is like almost like 4 milliseconds, and here is like 104 milliseconds. And in the meantime, the TLEAF service, see, it's like 3.7 and 12. That's not bad. So yeah, here what you can see is that this is good on the database side, on the connection side, and this is bad.
Okay, so it's the database. So what can we do to fix it?
So first of all, I think we should notify the networking team and the database team so they are aware, and hopefully they can fix it for us, because it seems that the issue is not on the application side. But we can also introduce caching, for example.
So you're saying that we would redeploy our applications with caching enabled, so they would process one request in a slow manner, right, until the cache is filled, and then the subsequent requests would be much faster.
Yes, because we will not call the database all the time.
Oh,
exactly.
Great. So we've managed to fix the problem. So before we start the weekend, maybe we can summarize what we've managed to see today.
Okay, let's do that. Can you do that?
Sure.
Thank you.
So to begin with, we've managed to jump from logs to traces and vice versa. That's because logs contain the tracing information. And by clicking the trace identifier from the logs, we could go back to the trace view. Same, going vice versa. So in the trace view, we could click show us logs for this particular trace identifier. We also managed to go from the traces to metrics. How was that possible? Because by using micrometer observation, we've managed to ensure that we have the same tags for traces and metrics. So we can create queries using the same tags and jump from traces to metrics. Finally, we've managed to correlate metrics with traces. How was it possible? Because we used exemplars. So we've managed to attach to some metrics a current trace identifier. Thus, we could jump from metrics to traces. Now, if you'd like to go from metrics to logs, you can do it through the exemplars, because you will jump from metrics to traces, and from traces, you can jump to logs. So how is that possible? Because in Spring Portfolio, we've managed to introduce micrometer observations. Things like WebMVC, WebFlux, and other Spring projects are natively using micrometer observations, so they are natively measuring different things, right? So how could we see interesting information in terms of the database and, for example, REST requests? That's because there's quite a few projects out there that are already using micrometer observations, such as JDBC observations for measuring JDBC-related metrics and traces, and, for example, OpenVein that has native support for micrometer observation. So now, Jonatan, can you tell us what's new in Micrometer 1.9.0?
Sure. So in Micrometer 1.9.0, which was released like 6 months ago, a little bit more, we added support for OTLP. And OTLP stands for OpenTelemetry Line Protocol. So if you want to use OpenTelemetry with the Micrometer API, you can just put the OTLP registry onto the class path, and each start publishing metrics in this OpenTelemetry format. We also added high cardinality text detector. And what it does, it tries to detect if you have high cardinality text in your metrics, because that can cause issues for you. And it will let you know on whatever channel you want. And what we already demoed, we introduced exemplars. So just to rehearse it, exemplars are kind of metadata that you can attach to your metrics. And you can attach like high cardinality data to your metrics, and this data will be sampled. And what we are doing, we are attaching the trace ID and the span ID to our time series so that we can jump from metrics to traces. And this is only available right now for Prometheus, because right now Prometheus is the only registry or backend that supports exemplars. But let me talk a little bit about some newer changes in Micrometer, because in November, we released Micrometer 1.10. And with this release, we also added new projects to the Micrometer portfolio. One of them is Micrometer Tracing. And Micrometer Tracing is basically the distributed tracing support for Micrometer. It is basically Spring Cloud Sleuth, just copied over from the Spring Cloud projects to the Micrometer umbrella. And we renamed packages, fixed a few things, renamed other things, and that is basically Sleuth. So right now, Micrometer is not only a metrics library, because it has tracing capabilities as well through the Micrometer Tracing project. We also introduced a new project called Micrometer Docs Generator. And what it does, it is basically, it gives you support for generating documentation for your instrumentation. So as you create your metrics and your traces, Micrometer Docs Gen will tell you what metrics were created with what list of tags, and the same for your spans as well. It's a really cool project if you want to tell other people what they should expect based on the instrumentation. So the other project, the last one that we introduced, is Micrometer Context Propagation. And Micrometer Context Propagation is basically solving this cross-cutting concern of context propagation in Micrometer, because with tracing, we need to do it. We need to propagate context through threads and through applications over the network. But it is the same problem that we had in the Spring portfolio. So Micrometer Context Propagation is there to solve these problems once, and everyone basically can use it and enjoy it. And the last one we would like to talk about is the Observation API. The Observation API is a new set of APIs that you can use with Micrometer, and Micrometer Core has it already. So if you get the latest version, you will get the Observation API as well. But hey, Marcin, do you want to talk about this?
I would love to. So let's talk about the Observation API in Micrometer 1.10. In order to measure things, you have to create and start an observation. So what is mandatory for the observation to have is the name. In this case, it's S1. And you have to pass in an observation registry. We will talk about that in a second. So the code you're seeing right now is instrumenting some piece of our business logic. So first of all, what we do after we have created the observation is we are putting it in scope. What that means is that you can, via the observation handlers, register certain resources. For example, you can put an object in thread local so that it's available for the business logic. And then when the business logic is done, automatically the scope is closed so you can free the resources. So the thread local variable can be cleared. If an exception happened, you should put it on the observation so that the observation handlers can act accordingly. So if, for example, for tracing, error information can be put on a span. Finally, never forget to stop an observation, because at the end of the day, you want to stop the timer that is measuring how long your method call took. Also, what you can do then is, for example, attach certain tags, which are the key value pairs. So now one can say, okay, we did manage to instrument some piece of code, but where all this magic, in quotes, happen in terms of adding metrics, tracing, etc. So this is specifically why we have created the observation handler abstraction. On the registry, you can attach the handlers, thus you can introduce behavior. So here you can see that we are attaching a meter handler, a tracing handler, a logging handler, an audit even handler, and you could pass all sorts of handlers of your choosing. Now, what it does with each of those handlers being added, that additional behavior happens. So with meter handler, we are adding metrics. With tracing handler, we're adding tracing. With logging handler, we can provide additional logging. So this is why you can separate the instrumentation logic. So you instrument once using the observation API, but you can have multiple benefits out of this. And those benefits are the handlers, the logic within the handlers. So in this case, if you then call observation start, all those handlers will be called, for example, to create spans and metrics. And then when you call stop, those handlers will be called again, so that, for example, you stop the timer or stop the span. So what else can you do with an observation? You can create it, but not start it. You have to provide the name in the observation registry, of course. And then you can manually pass in certain low cardinality or high cardinality key values. You don't have to be so verbose as we shown this a second ago in terms of opening the scope and catching the error. That's a lot of boilerplate code. What you can do is call the observe method. To the observe method, you can pass in the concrete method you want to observe, and we'll do the rest for you. If you don't want to call any of our API, no problem. Just use the @observed annotation that we provide, and of course register the aspect. And this is how we can create the observation for you, so you don't have to do anything else. So I guess now we've managed to fix all the problems related to bugs and latency in the tea house. And I guess we can safely give the floor to you back, Jonatan, so you can continue your presentation.
Oh, thank you for helping me fixing that.
Thank you.
Thank you. Okay, so that was the presentation. Thank you very much and goodbye.